All right, for this lesson, we're going to get into SolidWorks Simulation Express. And basically what this is it's a first pass stress analysis tool. So probably 30 years ago, we used to pay for FEA or finite element analysis to be done on parts. I had my company and we paid a lot of money for it. And now SolidWorks today basically has the power to do all that and more just sitting at your desk. So there's a lot of power in here, and what we're going to go through is just a really high level kind of introduction to how this can be used. And with Simulation Express, basically what they're going to give us is a wizard to kind of walk us through it, and it's still going to give us decent results. It's not the hard, like the full-blown simulation, which SolidWorks offers. They have a book and a full class that you can take, not at Harper, but you can take just on simulation analysis. And so this does a pretty good, kind of first level. So people ask why we do stress analysis, and um, there are so many reasons that I really can't explain them all. But just as a couple examples, so if we look at this part here and this boss here, if we had some sort of handle in here, and then we look at this hub, well, the hub's going to be connected to something that it has to turn. And so in order to turn it, we're going to need to put a certain amount of force on this handle. When this force is put on this handle, there's going to be a stress created on these spokes. And we could analyze this, a few different ways. And like one way that I could think of is, are these spokes thick enough or strong enough to resist this force that we're going to put on this rim here that's transferred down to this hub to turn whatever that hub is connected to. If they're not big enough, well, then these spokes are going to bend and they're eventually going to break. If they're too big, maybe we can reduce it and save material cost. And so, that's just one very small example, but there's all different types of situations where stress analysis is used. So you can look on page 236, and it kind of walks through the 7 steps that we're going to do to set up this analysis. And basically, we're going to start with options, and we need to set up the type of units for the materials, the loads, and the results, and they need to be common so they work together. Next, we're going to select what our fixtures are. And basically what the fixture is what part remains in place. And that's going to be kind of our base. And we're going to either rotate or put a force against it. Next, we're going to add loads. And we're going to have the loads are going to be the forces that act on either turning something, or maybe we put loads on a shelf to see how much weight it can withstand. But it's always going to be an external force acting on our part. We need to choose the type of material that we're testing. We're then going to run the analysis, and we are going to see if we need to adjust the mesh. And so what the mesh is, it's like, imagine a screen that is placed over this part, and that mesh can change either coarse to fine based on, you can think of like a very fine screen or a very coarse screen. And that is going to affect our results. If we have a very coarse screen, we're not going to get as accurate results, but it might get us in the ballpark, and it's going to run a lot faster. It's not going to take as much processing power as like a really fine mesh would. So again, it depends on what we have for resources, and it depends on what our needs are. And then last, we are going to, or not last, we're going to look at the results. We might have to put in a factor of safety, which means we don't want to, if something can hold 100 pounds, or we need something to hold 100 pounds, we don't want to design it to hold exactly 100 pounds. We want to design it to say, if we had a factor of safety that was like, it was really designed to hold 130 pounds, but we're only going to say it holds 100. So then if someone overloads it a little bit, we're still, kind of safe from, like a liability standard. Last, we're going to optimize the result using selected dimensions. Maybe we have to manipulate that and change things around a little bit. All right, so let's take a look at this. So one thing that you're going to have to do is you probably won't have this checked, but since I've got a tab here for simulation, this is different what we're going to do. Because we're going to be doing Express. If you have this tab here, you're going to need to go into Tools. You're going to need to come down to Add-ins, and you're going to unclick here and here for SolidWorks simulation. These two cannot run together. And then we're going to click OK. If you don't have the simulation tab up here showing, then you don't have to worry about it. And see, now that I unclick that, it disappeared. Okay, so now, oops, let me just adjust this. There we go. Now if we go to evaluate, now we should have Simulation Xpress Analyst Wizard show up over here up in the taskbar. And if I click on this, it's going to load it, and it should add it to the task pane over here to the right, which it does. The first thing we're going to do is we're going to click on Options. And I've already got it set, and you want to make sure that your system of units is set to SI, which is metric. This is the default location for the results, and we want to click this to show the annotation for max and min here. And then we're going to click OK. So I'm not exactly sure why the font size is so small on my task pane, but I'm going to kind of run through and show you what is what. So after we set the units, it's going to walk us through this 6 steps up here, and it's going to start. Hopefully you can see it's bolded, but like it says in the book, we're going to start with fixtures. Then we're going to come down with loads, material. We're going to run, and that can't highlight yet because we don't have anything loaded in. Then we're going to do the results, then we're going to optimize. So it wants us to apply fixtures to keep the part from moving when loads are applied. And then down here, we've got some different things here too, and it's different kinds of loads and fixtures. So, all right, we're going to stop this video here so they don't get too long, because we're probably going to need at least one more to finish this. So I'm going to end it here, and we're going to resume on the next video.